Let's take a look at some position and coterminal angles. So we've defined an angle as two rays that share a common endpoint, and that one ray is rotated away from the other, with that first side being called the initial side, and the side that's rotated is called the terminal side. To talk about an angle that's in standard position, what we do is take that angle and put it on the coordinate plane. For an angle to be in standard position, the initial side has to be on the positive x-axis. Then the terminal side is rotated away from that. Now, with this particular angle that I have drawn, because that terminal side is rotated up from the positive x-axis, this is a positive angle. However, if we start with our initial side on the positive x-axis and rotate that terminal side down, this would be a negative angle measure. So let's get some practice drawing what all these angles look like in standard position. Notice I have my coordinate plane here, and I also have a circle that's centered at the origin. That's there to kind of help remind us that we're rotating that terminal side around the vertex of the angle, and that there is a circular element to all of these angles. So let's start with the easiest one, that 90-degree angle. If we're going to draw a 90-degree angle, we need to have the initial side on the positive x-axis, and then the terminal side is going to rotate up from that, since we're talking about a positive angle measure, and we get this right angle here. So this is where our 90-degree angle would be. If we wanted to graph that 45-degree angle, we know that 45 degrees is half of 90 degrees. To be in standard position, we would still need to have the initial side on the positive x-axis, and then our terminal side would be about right here. And we can signal that angle by drawing in our arc and then writing the angle measure on that terminal side. Moving on to the 30 degrees, again, we would have to have our initial side be the positive x-axis. And then for where the terminal side is going to be, this is where that having a circle on our coordinate plane is kind of helpful, because we think about that arc from the positive x-axis up to that 90-degree angle. We know that 30 degrees is going to be a third of that, and so we kind of break this up into thirds, and that's where our terminal side is going to be, signaling that with an arc there and our angle measure on the terminal side. For an angle of 75 degrees, again, initial side on the positive x-axis, and we're going to want to rotate that terminal side 75 degrees. You're not going to be as exact with this one in general, but we're kind of estimating that arc. We've already identified that 30 degrees was right here, and estimated that 60 degrees was about right there, which would make 70 degrees, I don't know, somewhere in here. And there would be our 70-degree angle. What we're trying to do is really just get the terminal side in the right quadrant and approximately in the right position. This is just a good estimate. If you wanted to be accurate, you'd have to break out a protractor to help you measure that angle accurately. Here are a handful more. All of these are obtuse angles. They're greater than 90 degrees, but we can go through them one at a time, picking out the easiest one first. And I would imagine that 180 degrees is the easiest one. As always, we need to have our initial side on the positive x-axis. And when it comes to the terminal side, we know that the entire circle has 360 degrees in it. So half of that would be 180 degrees. So this would be our 180-degree angle. For an angle of 200 degrees, again, start with our initial side is the positive x-axis, and we just want to estimate where 200 degrees is going to be. It has to be more than 180 degrees, and we can estimate about where 30 is by each one of these quadrants, breaking it up into thirds, but then that would be 210 degrees. So we kind of shorten that up just a little bit and estimate our angle to be right here, with that being our 200 degree angle. With 100 degrees, again, start with initial side, positive x-axis. We know that 90 degrees is the positive y-axis, so if we go a little bit beyond that, just 10 degrees more, then that is where our 100 degree angle would be. So this would be 100 degrees. 150 degrees would be halfway between that 100 and 200. So again, we would still need our initial side as the positive x-axis, and then go about halfway between 100 and 200, or 30 degrees less than the 180. And that is where our 150 degree angle would be. Marking it right here. The last one, 300 degrees, we want to get it in the right quadrant and in about the right spot. So initially, we have to have our initial side as the positive x-axis. 300 degrees, well, I know 90 degrees is the positive y-axis. 180 degrees is over here as the negative x-axis. If we go another 90 degrees, we're at 270 degrees. So 30 degrees past that will bring us about right here. All right, now don't get tempted into drawing in your acute angle. This is not 300 degrees. 300 degrees starts on the positive x-axis and rotates around over to here. So this would be our 300 degree angle. When we're dealing with negative angles, we have to make sure that we rotate the other directions. Instead of rotating up from the positive x-axis, we're going to rotate down from there. So negative 90 degrees would be the right angle that goes down from that positive x-axis. We're going to do negative 45 degrees. Again, we always start with our initial side on the positive x-axis, and then the terminal side would be halfway between that 0 and the negative 90. So here is where our 45 degree angle, our negative 45 degree angle would be. For negative 270 degrees, well, we know that the negative y-axis is negative 90 degrees. We know that the negative x-axis is 180 degrees, negative 180 degrees. So there's negative 90. Here's negative 180. So negative 270 would be around over here. So we draw in that terminal side. Okay. We don't want to draw the right angle in because our negative 270 degrees is actually this. For negative 400 degrees, that one might throw you for a loop, but we start with our initial side on the positive x-axis, as always, and we want to rotate backwards 400 degrees. But if we go backwards one time around the circle, we're at 360 degrees. And how are we supposed to get to negative 400 degrees? Well, what we have to do is continue around past more than one time around the circle. And so our negative 400 degrees will have a terminal side right there. That's so that we have this little bit that's right in here, having that be about 40 degrees. Ooh, how about radians? Now there's a lot of people get very intimidated about radians, and that's okay, especially when it's your first time dealing with them, but they actually are very nice to visualize, and they can be very easy to use. When we're dealing with trying to draw an angle, a radian, angle, we still want to have our initial side be the positive x-axis, as always. But we have to think about in the entire circle. Remember, if we go all the way around the circle, what used to be 360 degrees is actually 2 pi radians. So if we only went halfway around the circle over to here, that would be pi radians. So here's another reason why having the circle put on our coordinate plane is a nice move, is we want to kind of visualize this arc here. And the length of that arc. When we're shooting for this pi over 4 radians, I know that if I were to cut this arc in half, that would be half of pi radians. So that 90-degree angle is actually pi over 2 radians. And if I want to get to pi over 4, I need half of that half, which would be about right here. So we would say that this angle is our pi over 4 angle. When it comes to pi over 3, again, we want to start with our initial side as the positive x-axis. And thinking about this entire arc, we want to cut that into thirds. So about here and here would make it thirds. So we want one of those thirds, and we could estimate our pi over 3 angle to be right here. For 2 pi over 3, well, that would be 2 of the pi over 3's. So again, start with our initial side on the positive x-axis. And instead of that 1/3, we want to go over here to 2 of those thirds. So this would be our 2 pi over 3 angle measure. Now when we draw an angle, just drawing an angle like this, it's in standard position. However, we don't know what the angle is. We maybe assume that it's this nice acute angle that's over here. However, we know that maybe that could be a negative angle. Maybe it could be this one that we're talking about. In fact, there's infinitely many different angles that look exactly like this one, because it could be another positive angle where instead of rotating that terminal side only that far, we let it go around the circle again. Or maybe we let it go around the circle again. Or maybe we let it go around the circle again. And then we could spin that terminal side infinitely many times around that circle and end up in the same spot. All of these angles being in that same position are called coterminal. Because of course, whenever we draw an angle, our initial side is always in the same spot. Right? However, it's that terminal side, the second side that's getting rotated around. If we have two angles that have different measures, but their terminal side is in the same spot, they're called coterminal. And the nice thing about them is that they're going to act exactly the same because they look exactly the same. So let's say we want to find the positive and negative angle that is coterminal to 130 degrees. If I kind of visualize where 130 degrees is, its initial side is the positive x-axis, and its terminal side is going to be about 40 degrees past 90. So right about there. This is what 130 degrees looks like. Now, if I want to find another positive angle that is coterminal to this 130 degrees, I need to let this terminal side take another trip around the circle. So if we started with 130 degrees, I'm just going to add one trip, 360 degrees, around the circle. And we end up with 490 degrees. And if we wanted to find a negative coterminal angle, we would start at this 130 degrees and take the terminal side and spin it back around this way. So starting with 130 degrees, instead of adding a trip around the circle, we would want to subtract a trip around the circle, which would leave us with an angle of negative 230 degrees. And when we're dealing with an angle that is measured in radians, to find coterminal angles, first I'm going to just draw it out to see where it is. And here's another nice thing that's nice about radian measures is that I know that pi is right here at the 180 degree mark. 7 pi over 6. Well, 7/6 is more than 1, right? It's 1/6 more than 1. So I'm going to add 1/6 of the way past the 180 degrees. And here is our 7 pi over 6 angle. Now, when we want to find positive and negative coterminal angles, what we're going to do is let the terminal side take another trip around the circle. So we're going to start with that 7 pi over 6. And I'm going to add a trip around the circle. When it comes to a circle, in radians, a circle is 2 pi radians. Of course, we want to add fractions, so we're going to get common denominators. 7 pi over 6, and if I were to multiply 2 pi by 6 over 6, we get 12 pi over 6. Adding them together, our coterminal angle is going to be 19 pi over 6. For the negative coterminal angle, instead of adding that 2 pi, we're going to subtract it. And remember, 2 pi is really 12 pi over 6, so 7 pi over 6 minus 12 pi over 6 is negative 5 pi over 6. And there are our positive and negative coterminal angles.